So, before getting started, as usual, I have posted the warm-up questions from lesson 7, which is AI agents. So, does any one of you wants to answer what is an agent? You can come out of mute and answer. Okay. So, so basically, LLM is a large language model. If you ask a question, it will provide a response. It's like a chart, right? I see a response from William, an AI that has the ability to use tools. Yeah, that's right. So LLM is basically you ask a question and it will give you the response. It will not interact with the tools. It will not execute the code. But with agent, it's an LLM. If you keep it in agent mode, it will understand your question, and to answer your question, if it has to interact with the external tools, then it will interact with the external tools and reads the response from external tools execution. And it will do this process on a loop until it has all the data required to answer your question. And then it will answer your question. So this is an exam. This is a definition of an AI agent, right? And my second question is, what are tools? I think the answer covers for this question too. So for the first time, when LLM reads the prompt, in the response, it will send a tools object if it has to interact with the tools, right? So that's another important point on tools, right? If the response has tools, then it's the indication that the LLM has to interact with external tools. So that is the idea. Okay. So let's start with the today's lesson. Um, can you all see my screen?
Yep, you're good.
Okay. So so in lesson 8, we talk about what is cloud. It's like an introduction to cloud computing. We'll discuss about why cloud is required, the benefits of the cloud, and different types of cloud providers popular in the market. Right. So those are the few things we will discuss in the week 8 lesson. Then we'll move on to week 9. In week 9, we discuss about Supabase. It's a Postgre database. We'll discuss about how to interact with Supabase, how to create a table, and how to do data operations like data insertion, data retrieval, data deletion, etc. So that is the agenda for today, for lesson 8 and lesson 9. Okay. So until now until now in the 7 lessons we discussed about creating a machine learning model, right? And then we discussed about artificial intelligence, LLMs, basically Gen AI, how to use ChatGPT APIs for chat completions and also for chatbot application, etc. Right. So now, now the idea is how do we use this generative AI in the cloud pipeline, right? Until now, we discussed all the things we discussed are being done in your system or in your local environment, but not in cloud. So now the next four lessons are like how do you run the Gen AI task in the cloud, or how do you use LLM in the cloud to enrich the data? So we are going towards that concept. That's why we are discussing about Supabase and introducing the cloud computing. Okay. So then, so intro to cloud computing. So basically, question to all of you: what is cloud computing? You can just guess and answer. No problem. Anyone? What is cloud computing based on your understanding? Right. Jenny says storage.
Computing that's done on remote devices other than a local machine.
Yeah, that's right. So, but what could be the benefits of doing that?
You don't need to actually have the devices or find a place to store them. It's happening remotely. And then the other benefit is that you can access those cloud computing components from any local device because it's all stored remotely.
Yeah, that's right. So, thanks for that. Um, yeah, and in the chat, Siddharth saying virtual computer, William saying advantage with the cloud computing is the scale and better hardware, CPU, GPUs, etc. From Stephen and from Laren, computing done on different devices that you have to own yourself. You don't have to own yourself. Yeah. Many updates and taking care of the devices is done from you. Okay. So yeah, thanks. These are all right answers. So um so the core idea is that sorry. So the core idea is simple. Instead of buying and maintaining your own computing resources, you rent resources from a cloud provider. Resources like storage, processing power, networking. And the catch here is you only pay for what you use. Let's say you are not using cloud. Let's say you bought 100 servers. Today you feel like you require 100 servers and you bought them. And tomorrow, for whatever reason, you are not able to use the 100 servers. You are only able to use only 10 of them. Then what should you do with the rest of 90 servers, right? So that's the question, right? So if you go with cloud, whenever you want 100 servers, you can enable for 100 servers and use them. Once your job is done, you can release them, right? And you pay for what you use, right? So yeah, rent a GPU cluster for an afternoon and then shut it down once you're done with the task, right? And you don't need to deal with outages You no need to deal with setting up the infrastructure, making sure those hardwares are functioning always. All that is taken care by the cloud providers, right? And yeah, those are some of the benefits of using cloud. So the popular clouds, the popular cloud service providers are Amazon Web Services, Google Cloud Platform, Microsoft Azure. So all of these are basically serve the same purpose, but they have different names of the services. But at the end, the kind of services they provide are the kind of same, but they have different names. Um, so um, so what does cloud does well? Scalability, right? Some of you already told scalability is one advantage with the cloud. Cloud infrastructure can grow and shrink with your workload in a way that physical hardware simply cannot. Right? In scaling, there are two types of scaling: vertical scaling and horizontal scaling. Vertical scaling is where you are making your one machine bigger, meaning more RAM, CPU, GPU. Horizontal scaling is basically adding the machines itself, right? You are adding more machines and spreading the work across the machines. That's called horizontal scaling. So clouds are capable of doing both. They You can do vertical scaling and horizontal scaling with clouds. So scaling is an advantage. Whenever you need extra services, want to scale the machinery, you can scale it up, um, and you can remove the usage of them when you are done. And then reliability. Did you notice any instance of Netflix going down anytime in the peak season? Let's say during Christmas time. Those instances are very rare nowadays, right? Because everyone, our large enterprises are using cloud, and cloud services guarantee that they are up 99.9% of the time. So the reliability is a big advantage by using cloud providers, right? If one location goes down, they'll route the traffic to the other location, other infrastructure. So that is one other advantage with the cloud. Um, yeah, beyond these, you can spin up a new environment in minutes rather than waiting for weeks for hardware to arrive to be configured if you want to configure in your own location or in your premises, right? So how cloud is delivered? There are three ways: um, infrastructure as a service, platform as a service, and software as a service. Right? An infrastructure as a service, basically you set up most of the things in the cloud, right? It's most flexible. Whatever you want, you can set it up by yourself, but it's more work for the consumer, right? When it comes to software as a service, so everything that you have to set up by yourself in cloud will be already set up. You just use that setup and pay for the services, right? So you just open the browser and use the app. You don't have infrastructure responsibility with software as a service. Some examples are Gmail, Dropbox, and Google Doc. Everything is installed configured for you. You just go and use it and pay for the usage. Whereas in infrastructure as a service, all the services will be there, but you need to set them up as per your need and then use it. In between, there is platform as a service. Um, it's kind of in the middle. You bring your own code, you deploy and run it and scale it. So these are the examples of platform as a service: AWS Elastic Beanstalk and Azure App Services. For infrastructure as a service, AWS EC2 and Azure VMs are there. So those are the types of cloud services these organizations provide. And and with cloud also there are like limitations or disadvantages. Let's say you scaled up, you want to use a GPU, so you took the GPU and you forgot removing it once the job is done and it's running overnight, then your bills will be increasing. So you need to set up the budget alerts always uh, to to safeguard yourself from the higher costs, right? And sometimes, let's say you want to do a task, and for the task, it requires just one computer. In such a case, it's ideally makes sense to do the task in your local environment or in your computer instead of going to cloud or leveraging the cloud, right? So, um, and if you have to use the cloud, then there is a learning curve. You need to understand how to use their platforms. You probably need to learn using their platforms, etc. Right? Um, that's why the big enterprises have a whole team for managing cloud operations or cloud computing operations. So, and another thing is cloud platforms change fast. They may come up with newer versions quickly. New things will be coming up. They might be deprecating few APIs, all that stuff. So LLMs are often behind on on understanding some of the cloud related stuff. So those are some of the cloud limitations, right? So these three cloud providers are called hyperscalers. That means they provide almost everything that is required and widely used in the industry. Apart from them, there are some other cloud providers. They can be used by developers. They are developer focused cloud services. So this is the list of those cloud services. Supabase, Firebase, Cloudflare, etc. Right? And for our course, we are using Supabase to perform database operations. These are the reasons it's easy to access, and you no need to wait for an invitation. Wait after an invitation. The account is self-provisioned. The Supabase account is self-provisioned. Earlier, previously, Microsoft Azure is used. It seems the provisioning was taking some time. I think that's why for this season, the course is designed with Supabase, it seems. So we will be using Supabase for this course, right? So here is some taxonomy for you to understand. I think you can check this taxonomy and understand, right? The developer tier platforms we discussed, Firebase, Supabase, yeah, taxonomy. Yeah, That's all for lesson 8. Um, so, any questions on lesson 8 before we move on to lesson 9? So, yeah, so lesson 9, I'll cover today. And this Friday's session, I'll reach out to CILs to mark it as already covered. So the Friday session won't be happening. And actually, on the 10th week Friday, I'll cover 10th lesson and 11th lesson. We start. Okay. Let's move on then to lesson 9. Yeah. So as I mentioned, for lesson 9, we'll discuss about connecting to Supabase. Um, we will create tables in Supabase and then perform operations, reading data operation, inserting data, and deleting the data operations. So, what is Supabase? Supabase is hosted PostgreSQL database with a Python SDK. Um, a web dashboard is there if you want to work with Supabase, and an auto-generated REST API is present with Supabase. Unlike file-based cloud storages, Azure and S3, Amazon S3 are file-based storage services. Supabase basically stores rows and columns like tables, right? Um, yeah, I think you can do all the operations you can do with SQL or other relational databases, right? So you have to, for any database, there is like setup, right? So um, you need to go to supabase.com and sign up for a free account, create a new project, give it a name, choose a region close to you, and set the database password. So wait for the project to finish provisioning. It usually takes less than a minute, it seems. Once the project is ready, you will land on the project dashboard, right? And then Supabase uses two pieces of information to identify and authenticate a client: project URL and an API key. So, you can, once you sign up, you can sign up, and once you are provisioned, you can find out this information in your Supabase dashboard, right? And you need to store credentials in the environment. So this is how you will do that: Supabase URL and Supabase key. You give the API key here. You give the URL to your project, and make sure that .env file is ignored from Git so that you don't push this secret information to GitHub. Right? If you end up pushing, someone can use your Supabase database, right? So that's the setup piece as usual, and already. I think you have worked with OpenAI client setup as well, right? So to connect with Supabase, you use create client function from Supabase. You're providing the URL and the key. You are creating a client. So once the client is created, you are basically verifying the connection. So before verifying the connection, you create a table in your dashboard. In your Supabase dashboard, you can go to table editor, create a small table called connection test, and then verify the connection by trying to retrieve the records from the connection underscore test table, right? And then you print the response. If you're getting the response, then you have made a successful connection to the Supabase, right? Um, and then working with tables in Supabase. So the idea here is to take two tables. Um, so so we ideally build an ETL pipeline in these four lessons where you do data extraction. E is extraction, T is transform, L is load. So you do data extraction, then you do transformation on the data, then you load the data, right? Um, so here we are working with weather data. So we are taking two tables. One table is to load the raw weather data, and the second table is to load the enriched data. Enriched data meaning we'll modify the raw data. Sorry. Um, or we add up new columns based out of raw data. So that is basically enriching the data, right? That data we insert in an enriching table, not in the same raw data table, right? So this is to distinguish between enriched data and raw data, and to do not interfere with the raw data, because raw data should be kept as it is if you want to check important details. So that's why the idea is to take two tables. One table is where you keep the raw data. In the other table, you keep the enriching data, right? So the raw data you should not override. That's why we are taking enriching table as well. So um, so we are taking two tables because let's say you want to understand which records from raw data were not enriched. So in order to understand this, you need to compare those two tables to understand which data is not enriched, right? So that's one other example where you need to preserve the raw data. So we are taking two different tables, right? Then here is how you create the table. It's simple and straightforward. You are keeping data as primary key. In the enriched table, data as basically, I think, a foreign key. It references weather underscore raw tables date. So this is like a foreign key, I believe. Um, so this is how this is the create query. And then by default, Supabase gives low row level security. That means it's read only. So for our lessons, we are disabling the row level security. We are saying alter table name, disable row level security. And here we look at performing CRUD operations, creation, retrieving, updating, and deleting, right? That's CRUD. So in order to insert, you created a record. You are saying Supabase table. You want to insert in weather underscore raw table, and calling insert, you are passing the record you want to insert, and you are calling execute. Then your data will be inserted. Similarly, for selecting your Supabase table name, select star, basically selecting everything in the table and then execute. The rows is list of dictionaries. You can iterate over it and print. If you want to select a specific column rather than all the columns, you can do like this. If you want to filter the data, basically like where ID equals to ID, right? So similarly, you have .eq. We are filtering out the data from the table where the date is equals to 1/15/2023. So that's how you use EQ, right? And you have upset. Upset is like if the record is present, it'll update the record. If the record is not present, it'll insert a new record. So that is upset. And for deleting, you have delete function. You are deleting the record whose date is 2023/11. So this is basically putting it all together. So that is how we do operations with Supabase database. Um, Here we look at extract plus load. Transform we'll discuss in upcoming lessons. Here it's extract plus load. So we basically extract the weather data and load in the Supabase database, right? There is an API, weather API. You were passing the latitude, longitude, start date, end date. You were querying for daily temperatures. So in the request, you are passing all these parameters to this weather API and you get the response. And you're converting that response to JSON response. And then you were reading the daily, day-to-day weather information and putting it into daily record. I would say it's a dictionary. And then you were creating records, is an array of dictionaries, I guess. Now you fetched the response and then you formatted the response in order to insert in a Supabase database. Here you were handling the missing values, then load the weather data to the Supabase table, right? We are saying upset records. All those weather records will be updated, will be inserted into the table. And this is basically to verify the data. If it is successfully inserted, right, you again retrieve it and print and see. So this is the complete code for extract and load. So that is lesson 8, lesson 9, sorry. So in lesson 10, we look at LLMs in pipeline. We use LLMs in pipeline to transform the data, right? Let's say you have customer reviews database in cloud. in the database, you want to enter one more column where the column name is sentiment. It will say sentiment positive or negative for each of the customer review, right? So in order to classify the customer review as positive or negative, that's called sentiment analysis, right? So that's for that sentiment analysis, we use LLM in the pipeline to do that sentiment analysis, and this is basically called data enrichment. So probably how do we do that? We will look in lesson 10, right? And lesson 11 is then putting all the pipeline into prefect. I think you already know prefect. We discussed in probably lesson 1. So how do how do we use prefect in the pipeline? So we'll discuss about that in lesson 11. So um, I see a question from Jenny. Let me see. When we create and set up project, should we connect it to our GitHub or GitHub repo right away? So you mean the Supabase project, Jenny? I think I did not understand your question. Okay. When you say connect it to GitHub repo, means pushing that code to GitHub repo. We basically from Python code you connect with Supabase. Okay. So in the Python code, you interact with Supabase database by using your project URL and Supabase API key. So GitHub is not here in between. GitHub is just for code versioning. You just upload your code to GitHub. You don't upload the sensitive data, which is your Supabase API key and your Supabase project URL, right? They will be in your environment file. They won't be pushed to GitHub. Uh, yeah, I hope I answered your question. Okay, it is asking if you want to connect to GitHub. Okay. Um, yeah, then I'm not too sure on that. I haven't tried all these steps by myself, so um, sorry, you can check it out on that. Okay.